This is part 2 of kind of the basics you need in order to get through this Newton's second law portion of the test. What you will need today, big part of today, is record the necessary information to read and create force diagrams. Also practice solving force, gravity when mass is given, and solve proportional mass, force, and acceleration problems. Let's see, today. This is the vocab for today. We're going to learn about these force vectors: force of gravity, force of friction, applied force, air resistance, net force, and acceleration. The story so far. Can you fill in the blanks here with yesterday's notes? On page 11. This is page 13, diagramming forces. Do not write this, but can you fill in the blank looking at yesterday's notes? Objects will only accelerate if there is an unbalanced force. Acceleration is indirectly related to mass and directly related to force. This will be our warm-up tomorrow. Here is a, we talked about all forces need an unbalanced, all acceleration requires an unbalanced force. So let's watch this person pitch. Going, going, going. Okay, let's look right here. Right now, I want you to just think to yourself, is this ball accelerating, yes or no, and why? The answer is it accelerating towards home plate? Is it accelerating this way? If you think the answer is yes, I want you to think back to what I just asked you. All acceleration requires an unbalanced force. So the question is, let's take a picture of it so I can write. I'll move this out of the way. What I would like to know is, what's the unbalanced force acting on this guy right now? If there's an unbalanced force pushing it towards the batter, what is it? Well, the answer really is nothing. There's nothing pushing it towards the batter. His hand is here. He's not in contact with it anymore, so when you're throwing something, as soon as it leaves your hand, you can't apply a force. As soon as it leaves your hand, it's not applying a force anymore, so it's not accelerating. The only direction that it is accelerating is downward. It's only accelerating downward. Everything else is just constant velocity in the x direction, constant Vx, because there's no applied. That's a really common misconception. It's not accelerating towards home plate anymore. It's only accelerating when you're touching something. Alright, so write down these notes on page 13 about force vectors. Direction matters. Oppositely directed forces cancel each other out. Number 2, length matters. Arrows should be longer if the force is greater. And the net force is solved when positive and negative values are established. So if you have an object and we've got 10 newtons and 15 newtons, well, you can pick. If you want this to be positive and this would be negative, well, guess what? You have a net force of negative 5 newtons. Next, we're going to skip this video. Next, notes on these are different types of forces you'll need to know. Applied force, write these down as a pushing, pulling, or the brakes from a car, only present when the object is in physical contact. Friction is a resistance force that opposes motion. It's usually pretty small. So if you put your hand on a table and you kind of slide it across, you can feel the table pulling back on your skin. Force of air resistance. Special type of friction. It's present in falling objects or objects moving quickly. So here's some examples. If you're pulling on a rope, pulling a box, this is the applied force this way, but the sliding on the ground is a little bit of friction backwards. Or, if an object is falling, force gravity is mass times acceleration. And then there's air resistance, pulling his hair up, that's slowing him down. And eventually, as you fall faster and faster, when they become equal, then you start moving at constant velocity. It's called terminal velocity. You can only fall so fast, and the air resistance is pushing up equally as gravity is pulling down. Force of gravity is same as weight. It's the down force. We'll use this idea a ton. You have this in your notes from yesterday, but not the weight part. Sometimes the textbook problems will call it weight. Fg equals mass times 9.8. Usually objects on flat surface feel an equal and opposite force from the surface. Write that down. Here's a picture, so you can just rewind the video if you need it. But gravity is down, and the table is pushing back up. So force gravity, solve for it right now. Using your notes from yesterday, solve for force gravity. Mass times 9.8. Alright, there's a quiz. I think I can show you how to take it. Can you wait a second? I'm going to pause it. Okay, using yesterday's notes, solve these questions. And for number 4, A equals gently apply brakes. B is slam brakes. And C is hit the wall. So answer these, pause the video, and then I'll give you the answers right now. So pause it if you don't want to see them yet. Force of gravity is mass times 9.8. 5 times 9.8 equals 49. Acceleration is 5, then mass doubles. That means the acceleration is half, 2.5. The original acceleration is 5 and force triples. That means you triple acceleration, 15. And the greatest negative acceleration is when you hit a wall. Gently applying the brakes, it takes you a long time to stop. Slam the brakes and you stop quickly. Hit a wall and you stop right away. So that's the greatest negative acceleration.